Okay, we are ready for our next presentation. I'm going to be inviting Marie Thiebault onto the stage. She is the Business Development Manager for 3 Year Mind. So Marie, welcome to the stage, and we look forward to hearing your presentation.
Hi, Melanie.
Hello. Thank you for joining us, and please go ahead and share your screen.
Okay, so can you see my screen? I understand you can see my screen. So hi, everyone. Hi, thanks a lot, Melanie, for the organization of Taipei conference. I'm super happy to be here and to be just after Valeria that talk a lot about sustainability in additive manufacturing, and we all feel like it's a very important topic. So from my side, I'm Marie Thiebault. I'm working at 3Year Mind as Business Development Manager. So I'm from France, and I have a background in the engineer. So I'm a materials science and engineer person, and I also did a master in management of innovation. And before joining 3Year Mind to more in a software for additive manufacturing, I worked in a foundry in aluminium in the automotive sector. So I'm very happy to be there today to talk about how to identify the spare part application within amount of data and within the spare parts. So before going deeper into the topic, I'd like to share with you two figures I found very interesting. So the first one is 56%. So these numbers come from a study led by EY in 2019 among 900 companies. And they found that 56% of companies expect that in 2022, the greatest benefit for applying AM will be reducing logistic efforts, transport, and inventories. And what is also interesting to notice is like back in 2019, only 26% of those companies found it as a key benefit. And other figure I find also interesting is this one, so 8%. So over the next 5 years, up to 8% of SQAs, which is stock keeping units, will be a better business case for additive manufacturing than conventional sourcing. This study also showed that around 2% of total units supplied could be produced in AM. So this result is driven by economical data. So you're looking at the low demand, the minimum order quantity, the high fixed cost, and also as well, of course, the technical information. So from our personal experience, when we work with customer, when we help customer to identify spare parts, we find between 2 and 15% of AM relevant spare parts. And of course, depending on the sector and the industry. So with these two numbers, we basically see that AM has a huge potential in spare part application. And all the question now is how to identify great spare part application, which criteria need I take into account to be able to analyze massively parts into my organization. So today, I would like to explain step by step the methodology that we are using with our customer to identify this AM spare part, starting with the data preparation, data acquisition, the part evaluation, and ending with digital inventory. It was what Valeria mentioned in the webinar before. And so at the end of the talk, I would like also to show you some concrete use cases. So one of them will be SNCF, which is the French railway company. So it's the first time that we showcase this use case. And I also share with you some other use cases. So let's deep dive on the topic. And first, we need to ask what challenges do we need to overcome to find new AM parts and to identify new AM parts. And Sculteo, a French service bureau, make a report last year, and they found that 68% of 3D printing users are looking for new application for AM. So this comes from first the lack of expertise, so the lack of AM expertise. So you want to start going into AM, but you or your employees just don't have the qualification in additive manufacturing yet. So maybe your engineers know well how to design for milling, for injection molding, but with regard to AM, they lack experience. So not everybody that knows a lot of your part well knows which one could be suitable for AM at the same time. So lack of expertise in additive manufacturing is one of the first problems we need to overcome. The next one is the lack of time. So let's assume that you have trained a few resources on AM and that a few qualified AM experts are available in your organization now. So now this small team of experts has plenty of work. They need to be sure that the design is well prepared for the printing. They need to be sure that the machine parameters are okay. They need to fill the quality requirements. So at the end, it's a lot of work. And we often see that in the company, the AM expert, the AM leaders are not 100% fully dedicated to AM. So they need to split their tasks. So we see that the lack of time as the second obstacle. The third one is related to the data and to the large search volume. So with additive manufacturing, the digital data availability on part level is a key challenge. So oftentimes we even don't have data, we don't have a 2D drawing. For example, we face with some customer material missing in most of the spare parts. So how can you qualified evaluate a part without the initial material of your part? So this is all the questions that need to be asked and answered at the beginning. And sometimes when we found the data, we figure that the data can be handled by different departments in the same organization. So all the challenge here is to identify which part you will need, to identify who is the owner of the data and how you can get the right information, the material, the size, the unit part price to be able to identify at the end if the part makes sense for additive manufacturing. And the last point is relating to the total cost of ownership. So here, basically, the pricing on part level is often intransparent to end user. We know that the machine return on investment is hard to reach sometimes. And regarding to the strategy of the company, it's hard for a company to decide if they want to make and buy part, if they want to produce internally all the parts, if they want to keep the production of some AM part internally and externalize other parts. So all the strategy make or buy is also one challenge to at least to answer at the beginning. And if you decide to externalize the production of AM part, you need to evaluate, qualify the suppliers. So this is the four challenges that we identified at our customers. And now the question is how we solve these challenges and the approach that we use to do with the company. The first step is to set up your business goal as a company. So me as a company, why do I want to use AM? Is it for cost reduction matters? So example, you have obsolete parts that are very expensive. So, and this part are still not produced, or it's just one supplier that produces the part. So you're looking to the cost reduction. Can be spare part decentralization, can be lead time reduction. So lead time reduction, the example, the classic example is when a train stops, it's from the transportation, a train stops because a part breaks. So you need to have this part as soon as possible. So we know that in this case, AM can make sense. It can be more for improving the part performance. reducing the weight of the part, having a more complex part, or it can even be for small part production. So this is some example. Of course, we can find other, but here the key is at the end of the day, you want to make sure to evaluate the part from the angle you want. So you want to be sure to have a return on investment at the end of the day. So seeing that, the data preparation, the next step is the data preparation and configuration. So the idea is to prepare the assessment structure within the software to make sure we take into account all data sets and all data classes to be necessary to achieve your goal. So again, the goal is the business goal that we mentioned just before. So this data can be general information. So you see on the slide the own IP right. You see some information related to the materials. Can be technical data, can be economical data, can be also legal information regarding the IP, who is the owner of the IP, and all the question or the information you have regarding the legacy of the part. What we figure out at this point is that the data is very different from one customer to another. So some customers have 3D file for every single part, and some other customers, they even don't have 3D file, PDF file. So this first step, which is also called the data mapping, is very important to understand what information is available and what is the information that we will need to, at the end, evaluate if a part makes sense for additive manufacturing. And of course, you want to do it in a more standardized way. So saying that, after there is the data acquisition. So here on the right, you can see an example of the type of sheet we obtain when uploading a part. So the idea is to have a comprehensive environment regarding the part you asset. So you can see on the top right the scoring of the part. And you can see two things, the technical scoring and the economical scoring from your part. So this score came from the technical and the economical data that you input. And based on the algorithm, we are able to calculate the score of the part. And higher the score is, better is the part for AM. So let's deep dive on the data sheet. So here for one part, so in the presentation, you can see an example from a turbocharger impeller. And in here, we have different information. So the general information regarding the part. And on the top right, you have the profile assessment. And basically, depending on the business goals that you've defined, the scoring can change. So in the example, it's the lead time improvement. It can be the cost reduction. And in this case, the score can change, of course. So you also can see on the bottom right, the technology assessment. So basically for one given part, you are able to check, if this part is feasible for one specific technology, for the MLS, WAM, or other type of technology. But you want to make sure that this part is available or is feasible for one technology, material, process. So next, and again, so we really believe, or at least I really believe that the key thing, if we want to scale additive manufacturing, is to collect massively data and to be able to evaluate massively data. So here in the example, you see an example of the report that you will have. So all the little dots are the parts that you asset. So basically, we see that in this report, on the top right, you will find the parts that are the most suitable for AM based on technical and economical criteria. But you also see the part that at this point doesn't make sense. What we want to make sure is like we store in the system all the parts, even the part that today doesn't make sense, because tomorrow if there are like a trouble on a part, a trouble with the suppliers, maybe this part will make sense for additive manufacturing. And when we talk about the part, so we want to have to store all the information in so in a digital inventory. And in your digital inventory, you want also to store all the production parameters. So if you need to validate and test the part, you want to make sure that all the information related to the part are stored in the same place to be able to create your digital qualified inventory. So saying that, I explained a bit the methodology. Now, I feel like let's go to the some use cases. So some concrete example where we follow this methodology. So the first one, as I was mentioning at the beginning, is SNCF. So SNCF, it's the French National Railway Company. So it's more than 250,000 employees. And SNCF, the main goal was to reduce the cost of spare part using AM. So the cost include, of course, the unit part price of the part, but it also includes the storage cost that was pretty high and other additional costs. So you want to reduce the cost of spare part, but you want to make sure to evaluate all the costs associated to the part and to compare it to all the costs associated to AM parts. So this was the main goal. We faced some challenge, and one of they were mentioning at the beginning. So regarding the data mainly, so poor technical information, no 3D file, the 3D file, messy ERP data, and lack of AM knowledge. So saying that, we were able to configure a platform, a full platform, with all the criteria, all the economical and technical data that makes sense for SNCF. And again, this depends a lot of on the industry, on the business goal, and other factors. So we were able to set up this full platform. And the first key benefits was the time that you save, having one platform where you can directly connect all the database into a system, and you have a pre-evaluation. So we estimate to save around 50%. And again, the platform was setting up to study metal 3D printing part and plastic 3D printing part. And on the right, you see all the results. And so over the 30,000 spare parts that we've studied, we found that 10.3% was relevant AM spare part on the economical and technical data. The second big thing we found was related to lead time. So over the 10.3% of parts, the average lead time was 2.5 months. And if you compare to the 10 business days of additive manufacturing, you can see the huge gap. And the last point regarding the savings, that was the main goal, we find out that considering the hypothesis of zero stock and 100% on demand, SNCF can save 1.1 million euros per year. And I'd like to maybe focus 1 minute on this point, because at the end, it depends on the strategy of the company, of your company. Do you want to go to produce AM spare parts only, or do you want to keep a minimum stock level at your company? What is the ratio you want to have AM printing part, AM parts in stock? So this is all the questions that can come up after this kind of analysis. So now I'd like to show you another example. So it's an example, again, from a railway company. So it's the German railway company, Deutsche Bahn. I feel very interesting because here in this use case, you will find another way of finding and identifying AM spare parts. So basically, Deutsche Bahn give the possibility to field workers, to operators, to directly go to the platform and fill a questionnaire and submit a part. The part is then evaluated by an AM expert that can decide if the part makes sense or not. So we've done a small video. So I feel it can be the right moment to show it to you.
simple way to interact with them. With the part identifier, they can fill in some basic information, material of the part, how it's called.
Hey, Marie, we can barely hear your audio. Are you able to turn it up?
Here, and we get a nice report with all the relevant information. We have an economic and technical score that indicates quite quickly if
Sorry?
We couldn't really hear your audio.
Okay, so let me put it a bit.
this part makes sense. For this part,
That's
3D
good.
printing was a The secondary road stop is a part that is bolted underneath the car body, and it limits the lateral movement of the car body relative to the bogie. So we're talking about 27 kilos of steel. It secures safe cornering and tight track curves. It was submitted using the part identifier with a CAD file. Producing this in a foundry, we would have to wait 10 months. Downtime will cost us some serious amount of money. So we decided quite quickly that we should print this part, and we were able to reduce the lead time by 5 months. The ideas of our colleagues are key to identifying suitable parts. They know their daily operation and they know exactly what could be improved. One of our colleagues from the business unit responsible for the stations all over Germany came up with the idea of using 3D printing for manufacturing handrail plates. I mean, normally, if you talk about cost reduction, you talk about 2 or 3%, 10%, but reducing them by 50% is quite a huge number. So this was a great success for us. The reason why we choose part identifier was to make our operation more efficient. We have a great funnel for filtering these ideas and structuring the information so we can process the data quickly. We want to reduce downtime for our customers, want to have all our assets in operation and not standing in our maintenance facilities. And that's what AM is delivering.
Okay, so I would just like to conclude regarding the topic. So you see that we really believe that to scale additive manufacturing, you need to standardize, you need a process to really assess your part massively. So of course there is some challenges that we've shown, but there is a way to do it and to be able at the end to only focus on the part that makes sense. So we showcase the example of the railway company. Oil and gas is also, so Valeria was mentioning oil and gas. It's also a very promising sector for spare parts. And maybe to finish, so Valeria was mentioning the sustainable topic. So this is also one big thing, and one big thing when you talk about spare parts. So also the thing is you want to evaluate the current spare part based, of course, on the technical data, the economical, and now based on the sustainable score or the CO2 footprint. So this is also one key thing that we need somehow to take into account when you talk about AM spare parts. So thank you all for attending the webinar. I don't know if you have any questions.
Thank you so much, Marie. Yes, there's a couple of questions coming through on the Q&A tab. So if any of the participants want to add any questions, go ahead and click on that Q&A tab and you can type in the question. One of the top questions is related to the scoring that you showed a little earlier in your presentation. How does the scoring account for the wide range of PM processes as well as changing technology landscape?
Yeah, no, that's a very good question. So basically, how we work, we basically work with our customers We have some customers saying, I want to look at one technology. So in this case, we set up the platform to be able to look at one technology. Sometimes they don't really have an ID, so we work with them to have the main technology. Sometimes it's even more precise, so they want a technology, but they want also specific materials. So it really depends on the way the company is working or their strategy.
Okay, great, thank you. So another question about the tool that we discussed. Is it something that's designed to use internally by a company or with the consulting support from Through Your Mind?
So yeah, it's also a good question. So the platform is not, so we don't have the same platform for our customers, so it's completely personalized. We have to customize it because it depends on the data that the company have and the business goal. So one company has its own platform. Of course, we are here to bring knowledge and to be able to set up the platform. But our idea is not to do consulting. The idea is to bring the tool for companies to be able to operate and to find IAM use case by themselves.
Okay, great, thank you. Another question from the audience. Do you manufacture as well as evaluate use cases, or are you partnered with any AM manufacturers?
So 309 is not. We don't manufacture, we don't produce parts. So for the technology check that you see in the software, so one DMLS, we partners directly with AM with machine vendors, with experts in technology. So it's the way that we set up the right algorithm, the right scoring. And we are able also to recommend, of course, some manufacturer, but it's not the core business of 309.
Okay, great. And another question is, what is your software called, or what is your software?
So what is the name of the software, right?
Yes.
Okay, so the name of the software is Agile PLM. I don't know if it answered the question, but the name of the software is Agile PLM, and it's within what we call a digital qualified inventory.
Okay, well, thank you so much, Marie. We are out of time, but thank you very much for the presentation. It was great to see all your use cases. So I will take you off stage and we will get ready for the next presentation. Thank you.
Yes, thank you all. Thank